We're gonna do a floating point representation question. So in this question, we know that both mantissa and exponent are represented by 2's complement, and straight away we know that mantissa is negative and the exponent is positive. So that we first calculate what the exponent is, which equals to 5, since it's 1, 2, 4. 4 plus 1 is 5. And then what we want to do now is to convert the mantissa into a positive binary number to make it easier for the calculations. In order to do that, we search for the first number 1 that goes from right to left. So we see the first one is 0, so we don't change that. The first U1, so we copy that down, and then the rest, so 0 will be flipped to 1, and the next one's going to be 0, 0, 1, 1, 0, 0, 0, 1, 0. We know now we know that it's a positive number since it starts with a 0. So since the exponent is 5, we have to count backwards by 5 between the 2 most significant bits. So 1, 2, 3, 4, 5. So we know decimal points this way. We know that this whole thing represents the first integer, and then this whole represents the decimal. So in order to calculate the decimal, it goes by the 2 powers of negatives. So the first one is 2 to the power of -1, 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4, 2 to the power minus 5, 2 to the power minus 6. So we know since there's a 1 in 2 to the power minus 1, and 2 to the power minus 4, and 2 to the power minus 5, we add them together. Plus, which gives you 0.59375. And now we have to calculate the number, the integer. 1, 2, 4, 8, 16. 16 plus 1 equals 17. Now we just add these two numbers. So it'll be 17.59375. And so first, initially, we converted this into a positive number, but initially the mantissa was a negative number since it starts with a 1, so we have to give the number a negative. And then now we have to calculate the normalized floating point representation of 5.25 in the system. Straight away, we know that 5.25 is a positive number, so we know that mantissa would start with a 0 since it's positive. And we're just going to calculate what 5.25 is in a normal binary. So you know that would be 101.01, since 1, 2, 4, 4 plus 1 is 5, and then this is 2 to the power of minus 1, 2 to the power minus 2, 2 to the power minus 2 equals 0.25. Since this is a normalized floating point, there should be no leading zeros, and there should not be leading ones, any leading ones. So the first two integers, first two bits should be different. So we know that it starts with a 1, 0, 1, 0, 1, and the rest we just put zeros. Now we have to calculate the exponent, which is the amount of times we have to move backwards from the two significant bits, between the two significant bits. So we'd go 1, 2, 3, because we know that this is where the decimal number should start. So the exponent should be 3, which is 1, 1, 0, 0. The exponent should be positive since we're going from left to right, and we know this is 3 because 1, 2, 4. 2 plus 1 is 3. So yeah.